Okay. So basically there's two markets here. There's QFC and there's Albertsons. They tell us that QFC has 75 markets. Albertson has 215. So they want us to compare the size of the two companies. But as I wrote here, it didn't tell us how to compare it. It didn't say, you know, find the absolute change, find the relative change. It didn't tell us how to compare. And what's kind of annoying about this one is, you know, it's kind of hard to tell which would be the initial, the starting quantity and the ending quantity. You know, it's not like in the previous example with the car, where the car started at 8,600 and decreased to 7,300. You know, there it was explicit what the starting and ending value were. We don't have that here. But there's different ways of comparing it. For one, if we did an absolute difference like this, so if we had Albertson was the ending quantity and QFC was the starting, then the difference would be 140. So in this case, Albertson has 140 more stores than QFC. But what if I mixed up the numbers? What if I did this? That's okay. It really means the same thing. You just have to know where the numbers are coming from. So in this case, it's the exact same interpretation. I just thought that, I mean, I'm not done with the example yet, but I thought this was a little bit different, so that's why I'm doing this. Now that's with absolute comparisons. What about percent change? Well, that's what I'm doing here. As you can see, since we don't know the starting and ending values, right, which is which, you know, there's different percent comparisons we can do. For instance, here, I'm saying, well, let's let QFC be the starting quantity. Then we get this as our relative change. As a percent, we would have 186.7%. In this case, Albertson almost has about 186% more stores than QFC, almost twice as many. As you know, I take that back, more than twice as many. For QFC, we would have this, if I switch the roles though of the numbers, so we had this then we would get this number. So in this case, QFC would have 65.1% less stores than Albertsons. Basically what I'm trying to show you here is you have to be careful with the numbers. You have to know what they're telling you. I know it's a little annoying with percent change, but that's just how it is. So you have to be a little bit careful here. Okay, all right. Okay, here's another, you're gonna love this. So with percents, okay, so here's one with buying a computer. You know, you see like sales and stuff with percentages, right? You see like, you know, something's marked down by a certain percent, okay? Well, here's an example like that. Okay, so we have a computer, right, at $970, and I'm telling you the computer's on sale. It's 45% off. We want to find the new price. Okay, you know, so imagine going into Office Depot or I guess Walmart also maybe. You know, you have a computer there that was $970, but they tell you it's 45% off, and you want to know the new price. Well, there's two ways of doing this. For the first way, if it's 45% off, right? One way is this. If it's 45% off, we're only going to pay 55% of the original price, right? So that's one way to look at it. And in that case, you get this as the new price. It's 45% off, so it's 55% of the original price. And that's what this is. The other way, the way you probably were thinking of if you have ever done this before, you get 45% of 970, right? But this is not the new price. This is how much they're taking off. This is the discount, in other words. So in other words, the amount you would pay would be this difference, which is the same price. It's just different ways of thinking about the problem. So I just thought it was cool to do it 2 different ways. So, but one way would really, I guess, be enough. I think the book does it both ways. So, so again, I'm just showing you, 2 different ways of buying this, of interpreting this. So hopefully that does help. Now the next one's going to be kind of tricky, so I probably should, let me do the next one with you as well. Okay? So here's this one. You're going to dinner and the bill comes and, somehow a tip is already included. With the tip, which is 7%, okay, everything comes out to $115.50. Now that's including the tip though, right? The question is, how much was dinner before the tip, without the tip? How are you going to pull that off, right? Well, I'm going to show you how to do that. What I'm going to do is I'm going to show you, I guess, algebraically, right? So let's say B is the bill before the tip, right? Then what the problem is telling us is B plus the tip is this. So B again is the original price, the original bill, adding on the tip, which is 7%, we get this. But they also tell us the tip is 7% of B. 7% of B. In other words, the tip is 0.07 times B. Okay, that's written poorly. Let me just fix that. Hey, come on. There we go. So we're multiplying it, in other words. It's almost like what's happening here is, it's kind of hard because we don't have that part over whole here, or is over of, I guess. But the tip is, we don't know what the tip is, but we know it's 7% of B. So so it would be 7% as a decimal times B. And that's probably confusing. I hope it isn't, but anyway, that's what the tip is, right? Okay, well, let's put that in here and see what happens. So we have this, right? What do we do next? We have B plus 0.07 times B. It's just like with polynomial. Oh, we haven't done that. So basically, we're adding like terms so we can factor out B, and we get this. Now we're ready to get B. We just divide. So again, basically, we're converting this into our algebra problem. And once you do that, you divide, you calculate, you get B. Did that make sense? Did that make sense to everyone? You could be honest.